Mastery practice questions number 1. Solve the equations 4 to the power of 2x minus 1 plus 4 to the power of 2x equal to 4. So first, refer to this law of indices. So the first terms here, 4 to the power of 2x minus 1, I can write it as 4 to the power of 2x times 4 to the power of negative 1. So when 2x plus negative 1, then you get 2x minus 1. So for these two terms, you have 4 to the power of 2x. Therefore, I can factorize this. So I'm going to write 4 to the power of 2x bracket 4 to the power of negative 1 plus 1. So 4 to the power of negative 1 is equal to 1 over 4. So 1 over 4 plus 1, then you're going to get 5 over 4. Next, I'm going to move this 5 over 4 to the other side. So 4 to the power of 2x equal to 4 divided by 5 over 4. Or you can write it as 4 times 4 over 5. So here you're going to get 16 over 5. Now, on both sides, you are not able to change it to the same base, then you cannot compare the power. In order for you to continue, you can use the log here. So now I'm going to log both sides with log base 10. So log base 10 of 4 to the power of 2x equal to log base 10 of 16 over 5. Now, using the power law here, I can move this 2x to the front. So it will become 2x times log base 10 of 4 equal to log base 10 of 16 over 5. Next, I'm going to move this log base 10 of 4 to the right hand side. So it will be log base 10 of 16 over 5 divided by log base 10 of 4. So solve this using your calculator. You're going to find that it is equal to 0.8390. So x is equal to 0.8390 divided by 2, which is equal to 0.4195. Questions number 2. Solve the equations 5 to the power of n plus 1 minus 5 to the power of n plus 5 to the power of n minus 1 equal to 105. So first, refer to this law of indices. So for the terms of 5 to the power of n plus 1 and the terms 5 to the power of n minus 1, we can write it as 5 to the power of n times 5 to the power of 1 and 5 to the power of n times 5 to the power of negative 1. So here we're going to have the common factor of 5 to the power of n. So we're going to factorize the left hand side. So in the bracket, you're going to get 5 to the power of 1 minus 1 plus 5 to the power of negative 1. So the bracket here, you're going to get 5 minus 1 plus 1 over 5. So solve for the value inside the bracket, you're going to get 5 to the power of n times 21 over 5. Next, we're going to move this 21 over 5 to the right hand side. Then you're going to get 5 to the power of n equal to 105 divided by 21 over 5. Or I can write it as 105 times 5 to the power of 5 over 21. Solve the right hand side and you're going to get the value is equal to 25. And then this 25, I can write it as 5 squared. So both sides having the same base, which is the number 5, then we can just compare the power. Therefore, n is equal to 2. Questions number 3. if square root of 5x equal to square root of 3x plus square root of 7, find the value of x in the form of square root of a over b. So here we want to find the value of x. So here we're going to move all the x to one side. So I'm going to move this square root of 3x to the left hand side. So it will become minus square root of 3x equal to square root of 7. So here, these two terms, we have the common factor of x. Therefore, I can factorize this. So x bracket square root of 5 minus square root of 3. To find the x, I'm going to move this square root of 5 minus square root of 3 to the right hand side. So here we want to write the answer in the form of square root of a over b. The b is just a number. Therefore, here we need to rationalize the denominator. So here we're going to multiply this using the conjugate surd. So the conjugate surd, you just look at the denominator here is square root of 5 minus square root of 3. Therefore, the conjugate surd is going to be square root of 5 plus square root of 3. Now, refer to this law of surds here. We can do the multiplication. So first, for the numerator part, it's going to be square root of 7 times square root of 5, which will give you the answer of square root of 35. Plus square root of 7 times square root of 3, which is square root of 21. Now, as for the denominator part, to do the expansions, you can refer to this. So the first one is going to be square root of 5 times square root of 5, which will give you the answer of 5. Then minus square root of 3 times square root of 3, which is 3. Therefore, the answer will be square root of 35 plus square root of 21 over 2. Therefore, here you already write the answer in the form of square root of a over b. Questions number 4. If log base x of a plus log base x of 1 over a equal to t, what is the possible value of t? So these two logs here are having the same base. Therefore, refer to the product law. I can write this as log base x of a times 1 over a. So this a and a here, we can simplify it. Therefore, you're going to get log base x of 1 equal to t. To find the value of t, we can convert these logarithm forms to index form. So, refer here. So now I can write this as x to the power of t equal to 1. So in order to get 1, any numbers with the power of 0 will equal to 1. Therefore, t is equal to 0. Questions number 5. The diagram below shows 3 circles. Circle A has a radius of 2 cm and circle B has a radius of 1 cm. PQ is a common tangent and all circles touch one another. Find the radius of the smaller circle. So first I'm going to draw a straight line that connects the tangents to the center of the circle A and B. Next, I'm going to draw a straight line that connects the center of A to B. So next, I'm going to draw another straight line here. So this horizontal line here is going to create a right angle triangle here. So now I'm going to label the information that I have. So the radius of A is 2 cm. The B is 1 cm. So now we can find the length of these horizontal lines using the Pythagoras theorem. So here the length is equal to 1 cm as well. Therefore, the length here is going to be 2 minus 1, which is equal to 1 cm. And let's say the points here, we label it as C. So here I already redrawn the right angle triangle here. So the length A to B is equal to 3 cm, AC is 1. So now using the Pythagoras theorem, I can find the length of BC. So BC is equal to the hypotenuse 3 square minus 1 square. So the answer is going to be the square root of 8. So now the length here will be equal to square root of 8. Next, I'm going to draw another horizontal line that passes through the center of the smallest circle. So now this one will be the radius of the smallest circle. Therefore, here is going to be equal to the radius of the smallest circle as well. Next, I'm going to draw two straight lines which are going to connect the center of the circle A and B to the center of the smallest circle. Now, it's going to create two right angle triangle here. So I'm going to label this right angle triangle as right angle triangle number 1 and this one as right angle triangle number 2. So here is going to be the radius of A. So here is going to be 2 and here is going to be the radius of the smallest circle. And for this line, this is going to be the radius of B, which is equal to 1. And this will be the radius of the smallest circle as well. And the length here is going to be 2 minus r. And the length here will be 1 minus r. So next, to find the radius of the smallest circle, we are going to use the Pythagoras theorems to find the length of these two horizontal lines, which we know is equal to the square root of 8. So this is the diagram of the right angle triangle number 1. So the hypotenuse here is going to be 2 plus r. And the length here is going to be 2 minus r. Therefore, the length of these sides is going to be, using the Pythagoras theorem, is going to be the square root of the hypotenuse, which is 2 plus r square minus 2 minus r square. And as for the right angle number 2, right angle triangle number 2, the hypotenuse is going to be 1 plus r and the side here is going to be 1 minus r. So the length of this side is going to be the square root of hypotenuse, which is 1 plus r square minus 1 minus r square. Now, when you sum up these two lengths, which is here, we know that it is equal to the square root of 8. Therefore, we can write this as, so now we are going to expand this. So here is going to be 4 plus 4r plus r square minus bracket. So here you will have 4 minus 4r plus r square. So this will be the square root plus 1 plus 2r plus r square minus, then put a bracket here, 1 minus 2r plus r square, and equal to the square root of 8. So now I'm going to get this thing out of the bracket. So it's going to be minus 4 plus 4r minus r square. Here we're going to get minus 1 plus 2r minus r squared. So now this 4 minus 4 is equal to 0, and this r squared minus this r squared is equal to 0 as well. Here 1 minus 1 is equal to 0. Positive r squared minus r squared is equal to 0 as well. So now here we're going to get square root of 4r plus 4r, which is equal to 8r, plus square root 2r plus 2r, which is equal to 4r. So next, for this square root of 8r, I can write it as square root of 4 times 2r. And for the square root of 4r, I can write it as 4 times r equal to, and the number 8, I can write it as 4 times 2. So here we can square root the number 4, which is going to give you the answer of 2. Therefore, here you're going to get 2 square root of 2r plus square root the number 4, you will get number 2 as well. So 2 square root of r equal to, here square root the number 4, you're going to get 2 square root of 2. So next, I'm going to divide every term with number 2. Therefore, you're going to get square root of 2r plus square root of r equal to the square root of 2. Next, I'm going to square both sides. So on the left hand side here, you're going to get square root of 2r plus square root of r times square root of 2r plus square root of r. And on the right hand side, when you have square root of 2 times square root of 2, you will get number 2. So on the left hand side, you just do the expansions. So first, square root of 2r times square root of 2r will give you the answer of 2r. And square root of 2r times square root of r, you will get square root of 2r squared. Plus, here you're going to get square root of 2r squared. And the last one is square root of r times square root of r, which is r. So here you're going to get 2r plus 2 square root of 2r squared plus r equal to 2. Next, we can square root this r squared. So when r squared, you square root it, you will just get r. Therefore, here you're going to get 2r times square root of 2. So here we have the r for each of the terms. Therefore, we can factorize this. So r, 2 plus 2 square root of 2 plus 1 equal to number 2. So here you're going to have r bracket 3 plus 2 square root of 2 equal to 2. Therefore, r is equal to 2 divided by 3 plus 2 square root of 2. Questions number 6. The temperature of a type of matter decreases from 100 degrees Celsius to T degrees Celsius according to T equal to 100 times 0.9 to the power of x after x seconds. Calculate A, the temperature of the matter after 5 seconds. So for questions A, we're just going to use the formula given, which is 100 times 0.9. So the x here, we're going to replace it with 5 seconds. So solve this using your calculator, you'll find that the answer is equal to 59.05 degrees Celsius. Questions B, the times taken x in seconds for the temperature of the matter to decrease from 100 degrees Celsius to 80 degrees Celsius. So here the T in the formula here, we're going to substitute it with the 80 degrees Celsius in order for us to find the X. So for questions B, I'm going to write it as 100 times 0.9x equal to 80. Next, I'm going to move this 100 to the right hand side. It's going to be 80 divided by 100, which is equal to 0.8. So now on both sides, you cannot change it to the same base to compare the power. Therefore, here we're going to use the logarithms. So here I'm going to log both sides with log base 10. Now on the left hand side, using the power law, I'm going to move the x to the front. So you're going to get x times log base 10 of 0.9 equal to log base 10 of 0.8. So to find the x, it's going to be log base 10 of 0.8 divided by log base 10 of 0.9. So solve this using your calculator, you will find that x is equal to 2.12 seconds. Questions number 7. After n years, the price of a car that was bought by Raju is Rm 60,000 times 7 over x to the power of n. Determine the number of years for the price of the car to be below Rm 20,000 for the first times. So the price of the car can be calculated using this formula. And we want to know the n, which is the number of years, when the price of the car is less than 20,000. So first, I'm going to move this 60,000 to the right hand side. It's going to be 20,000 divided by 60,000, which is equal to 1 over 3. So here I cannot compare the power as I don't have the same base on both sides. So here I'm going to log both sides with log base 10. So next, using the power law, I'm going to move this power of n's to the front. So it's going to be n times log base 10 of 7 over 8. To find the n, I'm going to move this log base 10 of 7 over 8 to the right hand side. Now, whenever you have the logs with the numbers here is less than 1, the value of the logarithm is negative. Therefore, when you move this log base 10 of 7 over 8 to the right hand side, as the value is negative, then the inequality signs here will be reversed. It will be greater than. So now solve this using your calculator. You will find that the n is greater than 8.227. So the number of years needs to be in whole numbers. So the nearest one greater than 8.227 will be 9. Questions number 8. Given log base x of 3 equal to s and log base square root of y of 9 equal to t, express log base 9 of x cubed y in terms of s and or t. So always refer to the logarithms law here in order to solve for the questions number 8. So first, for the log base 9 of x cubed y here, refer to the product law. I can write this as log base 9 of x cubed plus log base 9 of y. In order to get the terms s and or t, we need to change the log here in log base x and log base square root of y. So the first terms here, as is contain the x, I'm going to change it to the log in base x using the law here. So it's going to be log base x of x to the power of 3 over log base x of 9. And this number 9, we can write as 3 squared. And for log base 9 of y, as is contain the y, I'm going to change it to the log inverse square root of y. So I'm going to get log base square root of y over log base square root of y of 9. Now, for log base x of x to the power of 3, now refer to this law here, we're going to find that the answer is equal to 3. And for the denominator part here, move this number 2 to the front using the power law. You're going to get 2 times log base x of 3 plus, here the log base square root of y of 9. This one, we know that this is equal to t. So here I can write it as log bracket log base square root of y multiply 1 over t. So here we're going to get 3 over this log base x of 3 is equal to s. Therefore here we're going to have 2 times s, which is 2s plus, and for this log base square root of y, I'm going to, as this contain the y, I'm going to change this into the log inverse y. Therefore I'm going to get log base y of y over log base y of square root of y. And this square root of y, I can write it as y to the power of 1 over 2. So here I'm going to get 3 over 2s plus log base y of y, refer here, you will get 1. And for the denominator part, move this 1 over 2 to the front, or you can just refer to this law again. Straight away, we are going to find that the answer is equal to 1 over 2. So here is 3 over 2s plus, so when 1 divided by 1 over 2, you get the answer is equal to 2. So when it multiplied by 1 over t, here you're going to get 2 over t. So that is the answer. Questions number 9. 2 experiments were carried out to find the relationship between the variables x and y. Both experiments show that the relationship between the x and y is in accordance to 3 times 9 to the power of x equal to 27 to the power of y, and log base 2 of y equal to 2 plus log base 2 of x minus 2. Finds the value of x and y that satisfies both equations. So here we have 2 variables, x and y. To solve this, we're going to form 2 equations. Then later on, we're going to solve it using the method of simultaneous equations. So first equations, we're going to get it from here. So here I can write it as 3 times this number 9, I can write it as 3 squared. Therefore, I'm going to get 3 to the power of 2x equal to 27. I can write it as 3 cubed. Therefore, I'm going to get 3 to the power of 3y. So on the left hand side, you are having the same base. Therefore, I can, and the operation is a multiplication. So I can just plus the power. So 3 to the power of 1 plus 2x equal to 3 to the power of 3y. So now both sides are having the same base, which is number 3. So I can just compare the power. Therefore, 1 plus 2x equal to 3y. So this is our first equation. And the second equation, we're going to get it from the log here. So here, I'm going to write it as log base 2 of y equal to, and for this number 2, I'm going to write it in the form of log. So first, I'm going to write it as log base 2 of 2. So this is equal to 1. So when you put in the power of 2 here, then this will equal to number 2 plus log base 2 of x minus 2. Now, on the right hand side, using the product law, as these two laws are having the same base, I can write it as 2 squared. I'm going to write it as 4 times x minus 2. So now I'm going to have log base 2 of 4x minus 8. So now on both sides, they are log with the same base. Therefore, I can do the comparison now. So y is equal to 4x minus 8. So now we have two equations. So this one I'm going to label it as equations 1. This one as equations number 2. So here I'm going to use the substitution method, and I'm going to substitute equations 2 into equations 1, as I have the y in the equation 2 as the subject of the formula. So here I'm going to get 1 plus 2x equal to 3y. The y here, we are going to replace it with 4x minus 8. Expand this, you're going to get 12x minus 24. I'm going to move this negative 24 to the left hand side. It's going to be plus 24 equal to 12x minus 2x. So 25 is equal to 10x. Therefore, x is equal to 25 over 10. So simplify this, then you're going to find that the answer is equal to 5 over 2. So now to find the value of y, I'm going to substitute x equal to 5 over 2 into equations number 2. Therefore, I'm going to get y equal to 4. The x here, replace it with 5 over 2 minus 8. So solve this, you're going to get this one is equal to 10 minus 8. Therefore, y is equal to 2. Questions number 10. The price of the car drops and can be determined with these equations given. So in these equations, the car with Y years of usage and price RMQ will drop to RMP after being used for X years. So a car is bought as RM 100,000, has 20 years of usage. If the price of the car drops to RM 10,000, so finds the years of usage for that car. So first, this RM 100,000, this one is the RMQ, so the initial price. This 20 years of usage is referred to the year Y, and the price dropped to RM 10,000, this one is the RMP. So the years usage for the car, this one is referred to the X. So now we're going to substitute all the informations into the equations given. So it's going to be x times log base 10 of 1 minus 2y, the y is 20 here, equal to log base 10 of p, so 10,000 minus log base 10 of q, which is the 100,000. So here I'm going to get x times log base 10 of, so here solve this, you're going to get this is equal to 9 over 10. And on the right hand side, using the divisions law, I can write this as log base 10 of 10,000 divided by 100,000. So here I can simplify this. It's going to be 1 over 10. So now this is going to be x times log base 10 of 9 over 10 equal to log base 10 of 1 over 10. We can write it as 10 to the power of negative 1. So to find the x, the value here, log base 10 of 10 to the power of negative 1, this is equal to negative 1. And we're going to divide it with log base 10 of 9 over 10. So solve this using your calculator, you'll find that the x is equal to 21.85 years.